So once again, welcome back to the next session of the P block elements 2. As we have discussed the group 16 and the group 15, we are going to begin with the group 17, which is halogen family. The halogen family includes the properties exhibited by the chlorine, its uses, then followed by the trends involved in the physical and the chemical properties of this halogen compound, then followed by the interhalogen compounds, finally the oxides formed by the halogen. We are ending up with the group 17. To begin with, this group 17 halogen. Halogens contains chlorine, bromine, fluorine, iodine, astatine, tennessine. Okay. So based on this, we are studying certain compounds alone in this content. The halogen, which is not existing as an separate or in an atomic form, but it exists in the form of a combined form, since it is highly reactive. Obviously, fluorine or chlorine or bromine or iodine will try to gain one electron to attain the octet configuration, which means it will always try to find an electron. So that's why it is more reactive. So it is not possible for the halogen to exist ideally as an elemental form itself. So that is why it exists in the form of a combined form. Right. Fluorine exists in the form of a fluorspar. Fluorspar is calcium fluoride. Fluoride, that's what? Fluoride, CaF2, cryolide, Na3AlF6, then fluorapatite, CF5PO4 thrice, and F. Okay. So this is F, fluorapatite. Then chlorine, majoritarily it is present in the seawater. From the seawater we can able to prepare by the electrolysis of this brine solution. We are going to look into it. See, bromine and iodine is also present in the seawater, but it's a minimum quantity when compared to the chlorine and fluorine. Okay. Then regarding this physical properties. Physical properties, if we look into it, fluorine and the chlorine exist in the form of a gas, bromine in the form of a liquid, iodine and acid in a solid. Okay. And the atomic number, atomic mass, radius, density, melting point, boiling point definitely will increase from fluorine to astatine. No doubt in that. Regarding its electronic configuration. So fluorine, chlorine, bromine, iodine, astatine, tennessine. So begin with fluorine 9. To that you need to add 8. So the chlorine becomes 17. To that you need to add 18. So in such a way 8, 13, 18, 18, 32 you need to add. Then after which you need to enclose with the noble gas configuration helium, neon, argon, krypton, xenon, radon. Then after the helium it is the general electronic configuration of this group is Ns2Np5. Okay, 2s2 2p5, 3s2 3p5, 4s2 4p5, 5s2 5p5, 6s2 6p5. Before 4s 3d comes 3d10. Before 5s 4d comes 4d10. Before 6s 4f14 comes 5d10 6d10 comes. So this is regarding the electronic configuration of the elements. Regarding the manufacture. See, chlorine is being prepared by the electrolysis of the brine solution, which is nothing but the seawater, salt water. Or you can do the process called oxidation of HCl with the help of a decadence process. Both ways has been given. We'll look into it. First one, electrolytic process. See, NaCl, if you electrolyze it, it's split into Na plus and Cl minus. Since water molecule is also present, water molecule also undergoes electrolysis to form H plus and OH minus. So this Na plus will take up this OH minus and forms NaOH, sodium hydroxide. So here the chlorine that has been formed here, Cl minus, will go to the positively charged electrode called anode. At anode, chlorine which is present here will get oxidized to Cl2 by losing 2 electrons. Thereby chlorine will go out of the reaction as a chlorine gas. Then cathode, the H plus ion which is present here will take up the electron given by the chlorine. So thereby it has been reduced to hydrogen gas, that is also goes out of the chamber. See, in such a scenario, chlorine goes out, hydrogen goes out, the remaining solution is definitely a basic solution because of the formation of this sodium hydroxide. So this is what happens in this decadence process. The next one, oxidation. Sorry, the electrolytic process, the very first one we have seen. Next one is decadence process. In the decadence process, what we need to do is, we need to take a chamber. The chamber should have a many number of shells in which pumice stone should be soaked with the cuprous chloride. So this is what, we need to take a chamber. The chamber should have a many number of layers, that is what shells. And it has been, so the pumice stone should be soaked in a cuprous chloride. So that is what has been given. And to the chamber, you need to pass the mixture of air and hydrochloric acid from one side. and hot gases at 723 Kelvin is being passed to the other side of the chamber which surrounds the jacket, which means assume that this is the chamber. This is the chamber. Over the chamber you will find a jacket where the hot gas will be flown into it which surrounds the chamber, so that the temperature can be maintained at 723 Kelvin. So this is what regarding. So during the course of the reaction, what happens? Hydrochloric acid will react with the oxygen at 400 degrees Celsius in the presence of a cuprous chloride to form water molecule and chlorine. So 2 oxygen, so here it is 2, hydrogen becomes 4, so here it is 4, chlorine becomes 4, so here it is 2. That's all. Okay, the chlorine that obtained is quite dilute because it has water in it, so it has been used for the preparation of the bleaching powder. Then similarly, the cuprous chloride which we have Cu2Cl2 reacts with oxygen to form cuprous oxychloride Cu2OCl2. So this is to balance with. Okay, so cuprous oxychloride. The cuprous oxychloride will react with the hydrochloric acid to form cupric chloride CuCl2 and water molecule. CuCl2 and water molecule. So to balance with the chlorine, I need to make it as 2 here. So that chlorine becomes 2. Copper is already 2 here. So chlorine becomes 4. Here also it is 4 balanced. Oxygen, hydrogen, if I make it as, that's all. It is balanced. It is very clear. Then the cupric chloride CuCl2 is further forms Cu2Cl2 cuprous chloride plus chlorine. So chlorine there it is 4. So if I make it as 2, equation is balanced. So this is a consecutive reaction which happens there. Initially in a chamber which is surrounded by a jacket in which the hot gas is passed about 723 Kelvin which surrounds the chamber. To the one side you are passing the mixture of this air and HCl, and the chamber contains the number of shell in which the pumice stone is soaked in cuprous chloride. So the following reaction takes place. First, it forms chlorine gas. This chlorine gas has a water molecule in it, so used for the preparation of the bleaching powder. Initially, the cuprous chloride is oxidized to cuprous oxychloride, and cuprous oxychloride further oxidized to cupric chloride. Cupric chloride is further reduced to cuprous chloride. So this is what. So in the end, chlorine gas has been prepared. So this is what happens in this decans process. The next one, physical properties. See, if you look into the physical properties, this chlorine is a greenish yellow gas and pungent odor. Pungent odor in the sense is irritating odor. That's what it means. See, if you inhale, it produces a headache here, no doubt in that, in small quantities. But when you inhale in the large quantities, it may result in the death. That's what fatal. Okay. If you compare the mass of this chlorine with the oxygen, it is 2.5 heavier than air. Here, air actually represents the oxygen. Then its solubility in water is, this is quite soluble in water. That's why it is called as a chlorine water. In the swimming pools for the cleansing purpose, it has been used. Chlorine water has been used, which means into the water, chlorine will be passed. Okay. So that is regarding that. So since it is more soluble in the water, it forms an hydrated salt also. So chlorine octahydrate, which is a greenish yellow color crystals. Okay. This gaseous chlorine can be liquefied, can be liquefied by maintaining particular temperature and the pressure. Here the boiling point of this liquid chlorine is minus 34.6 degrees Celsius. This boiling point is only for this liquid. Okay. The yellow crystalline solid that has been prepared, greenish yellow solid, its melting point is minus 102 degrees Celsius. So these can be asked as an Byharding type of questions. Okay. What kind of an hydrate formed by the chlorine? It is Cl2.8H2O. If it forms, what is the color of the hydrated salt? It is greenish yellow crystal. When whether the gaseous chlorine can be liquefied? Yes. If liquefied, what's the boiling point of the liquid chlorine? It is minus 34.6 degrees Celsius. Then what is the melting point of this yellow crystalline solid? It is minus 102 degrees Celsius. So in such a way, the questions can be asked from the physical properties. Okay, these are all the Byharding type of questions. Then its chemical properties. See, when chemical properties here includes action with the metals and non-metals, it's quite easy. Sodium reacts with chlorine to form NaCl. Then iron reacts with chlorine to form ferric chloride, FeCl3. So 2 here, 3 here, 2 here. Then aluminium reacts with chlorine to form aluminium chloride, AlCl3. So 2 here, 2 here, 3 here. Then copper reacts with the chlorine to form cuprous chloride, Cu2Cl2. Then hydrogen reacts with the chlorine to form hydrochloric acid. See, in all the state, the oxidation state of the chlorine is being reduced to -1 here. That's the only thing that's quite notable here. Okay, obviously the metal will oxidize, chlorine will reduce. So this is what the reaction will happen here. Metal is electropositive, obviously it will undergo oxidation. Chlorine is electronegative, definitely it will undergo reduction. Then with the boron, boron is a non-metal. Okay, with the boron it forms boron trichloride. So boron reacts with chlorine to form boron trichloride. Then sulfur reacts with chlorine to form disulfur dichloride S2Cl2. Then phosphorus reacts with chlorine to form phosphorus trichloride 6 here. Arsenic reacts with chlorine to form arsenic chloride AsCl3, arsenic chloride, to balance with 2 here, 2 here, 3 here. Antimony reacts with the chlorine to form antimony trichloride SbCl3. So here it is 2, here it is 2, it is 3. So this is what the reaction which happens with the non-metals. And again, affinity for the hydrogen. See, turpentine has a molecular formula C10H16. When it treated with the chlorine, all the carbon will comes out, 10 carbon will go. Then 16 hydrogen will take up the 16 chlorine and goes as 16 HCl. So this is the byproduct. And the chlorine, when it is treated with the water, in the presence of a sunlight, it loses its color and its smell and forms molecular oxygen and hydrochloric acid, HCl. Okay, so here I need to balance it as 2. So hydrogen becomes 4. So 4 here. So here it is 2 balanced. Okay, so this is what the reaction happened to show that it has an affinity for the hydrogen. Next one, action of ammonia. See, with ammonia, 2 types of the reaction can happen, with excess chlorine and with excess ammonia. When ammonia reacts with the chlorine, it forms dinitrogen N2 plus HCl. So balance with hydrogen, here it is 3. So if I make it as 3, hydrogen, chlorine cannot be balanced, I can write it as 2. So nitrogen is 2. So chlorine is 6, here it is 3. Then the hydrochloric acid that has been formed will react with the ammonia further and forms ammonium chloride NH4Cl. Since it's a consecutive reaction, overall reaction should be written. I need to take the 6 here, here it is 6, so here it is 6. So to write the overall reaction, HCl gets cancelled because it's quite opposite to each other. Then rest of the things will come. 2NH3 plus 6NH3, 8NH3 plus 3Cl2 gives N2 plus 6NH4Cl. So this is what the with excess chlorine. With excess chlorine here, it forms NCl3, nitrogen trichloride. So ammonia reacts with chlorine to form nitrogen trichloride NCl3 plus HCl. So hydrogen, there it is 3, so here it is 3, chlorine becomes 6, so here it is 3. So nitrogen is 1, equation is balanced. Then similarly, hydrochloric acid that has been formed will react with ammonia further to form ammonium chloride NH4Cl. The same thing, 3 here, so 3 here, 3 here. So the overall reaction can be written, HCl gets cancelled, then ammonia 4NH3 plus 3Cl2 gives NCl3 plus 3NH4Cl. So this is what regarding the excess chlorine. The next one includes oxidizing property. Okay. The hydrogen sulfide is oxidized to, in which the sulfur is being oxidized to sulfur. Okay, yes, -2 will be reduced, oxidized to 0. So H2S plus Cl2 gives HCl plus S. So 2 here. So chlorine and hydrogen is balanced, sulfur is balanced. That's all. Then chlorine reacts with the potassium bromide KBr. Potassium will take up the chlorine and goes as 2KCl. Therefore, bromine will be oxidized. Then chlorine reacts with potassium iodide Ki to form KCl. Iodine will be oxidized. This fluorine this chlorine cannot oxidize the fluorine, because fluorine is a excellent oxidizing agent when compared to this chlorine. That's why chlorine cannot oxidize this fluoride. Okay. Next one, action of alkali. See, with alkali, the reaction goes in two different ways: cold dilute alkali and hot concentrated alkali. See, in the cold dilute alkali, the reaction goes like the chlorine first reacts with the water molecule and forms hydrochloric acid and hypochlorous acid. So I'll write. See, so the chlorine will react with water to form HCl and HOCl. Then the hydrochloric acid will react with the sodium hydroxide and forms sodium chloride plus water. Similarly, the hypochlorous acid, very firstly HCl reacts with NaOH, then secondly HOCl reacts with NaOH to form sodium hypochlorite, NaOCl plus Na1, hydrogen 2, oxygen 2, chlorine 1. So equation is balanced. Okay. So these are all the reactions which happens there. If you look into it properly, the whole reaction includes the formation of this HCl and HOCl. Okay, only formation of HCl and HOCl begins with the reaction. Okay, so this is what. So the overall reaction includes like chlorine reacts with NaOH to form NaOCl plus NaCl plus water. Okay, so I need to balance it. So sodium here it is 2, there it is 2, here it is 1, so it is 2 here. So oxygen is 2, okay, hydrogen is 2, chlorine is 2, sodium is 2, equation is balanced. That's all. Okay. Then hot concentrated alkali. In hot concentrated alkali, the reaction goes in different ways. See, very beginning, as we have seen previously, water molecule will definitely form HCl and H, as we have seen previously. Okay. Now, this and forms bread and water. This is also we have seen. Okay. So equation is balanced here completely. Then this hypochlorous acid that has been formed, HOCl. Okay, I'll write here. This HOCl will react with this NaOH and form NaOCl plus H2O. Then the sodium hypochlorite that has been formed will further react here. The sodium hypochlorite NaOCl further reduced to NaCl plus NaClO3, sodium chlorate and sodium chloride. So to balance with, I need to check. If I make it as 3 here, chlorine becomes 3. So if I make it as 2, that's all. Okay, sodium is 3 on both sides, chlorine is 3 on both sides, oxygen is 3 on both sides. Equation is balanced. Okay, so the overall reaction actually includes chlorine reacts with NaOH to form NaOCl plus NaCl plus H2O, water molecule. So to balance with chlorine 2, there also it is 2, sodium 2 there. So if I make it as 2, sodium is 2, oxygen 2, hydrogen is 2. Equation is balanced. Okay. Then next one regarding the preparation of the bleaching powder. The preparation of the bleaching powder includes the calcium hydroxide, slake lime on treatment with chlorine. So water molecule will be formed as a byproduct. Then your product can be, so H2O goes out, one oxygen is left out. So it is CaOCl2, calcium oxychloride. Okay, equation is balanced there. The next one is oxidizing agent. The reaction to show that it is an excellent oxidizing agent. Chlorine is a strong oxidizing agent, no doubt in that, because it produces the nascent oxygen in it. See, the hypochlorous acid that has been formed is further reduced to HCl, thereby nascent oxygen has been produced. So chlorine reacts with water to form HCl and HOCl. As I said, the hypochlorous acid will further reduce to HCl by evolving the nascent oxygen. Because of the presence of this nascent oxygen, this actually oxidizes colored product to the colorless product. Okay. This sulfur dioxide bleaching action is not permanent, it is temporary. This bleaching action of the chlorine is quite permanent. It forms a colorless oxidation product as a final product. That's it regarding this. Then, as I said, the bleaching action of the chlorine is permanent. It has an ability to oxidize this ferrous ion. So, FeCl2 plus Cl2 forms FeCl3. So, here it is 2. So, here it is 2. Okay. Then, reminding us, the very first reaction that is very known to us for us, which is the formation of the hypochlorous and hydrochlorous acid. See, first chlorine reacts with the HOCl and water molecule to form HCl and HOCl. So, chlorine will react with the water and forms HOCl plus HCl. The ferrous sulfate FeSO4 reacts with the sulfuric acid and the hypochlorous acid HOCl and forms ferric sulfate Fe2SO4 thrice plus HCl plus H2O. Okay, so to balance with sulfur, left side, right side it is 3, left side it is 2, iron there it is 2, so I will made as 2 here, so sulfur is balanced, fine. Then I need to check with the chlorine, that side here also 1, here also it is 1, hydrogen 3 here, there also it is 3, fine, oxygen I need to check, 8 plus 4, 12, 12 plus 1, 13. Here it is 12, 12 plus 1, then equation is balanced. Okay, right. So, to overall reaction can be written as ferrous sulfate FeSO4 reacts with H2SO4, then chlorine to form ferric sulfate Fe2SO4 thrice plus HCl. Okay, plus HCl. So, this is what the reaction goes. So, sulfur there it is, iron it is 2, so I will make it as 2 here. So, hydrogen 1 there, so I will make it as 2 here, hydrogen is balanced, chlorine is balanced, oxygen 8 plus 4 is 12, there also it is 12, equation is balanced. Okay, so regarding this, that's it. Okay, so if you can balance this, you can write up from this reaction also by cancelling that HOCl and HOCl, that's all. You can just sum up and you can just write. Okay, then water molecule gets cancelled. That's all. So, Cl2 plus 2 FeSO4 plus H2SO4 gives 2 molecules of HCl plus Fe2SO4 thrice. So, it oxidizes ferrous ion to the ferric ion. The next one. It oxidizes sulfite to the sulfate. So, because of the very first HOCl, because of the ionized oxygen produced by the HOCl, it has an oxidizing property. So, let me take sodium sulfide Na2SO3. Sodium sulfide reacts with hypochlorous acid HOCl to form sodium sulfate Na2SO4 plus HCl. One of the oxygen will be taken up by this and forms an HCl. So, this is what. So, overall reaction can be written HOCl cancelled. Then, so that's it regarding that. So, Cl2 plus Na2SO3 plus H2O gives Na2SO4 plus HCl. So, that's it regarding. Okay. Then, it has an ability to oxidize sulfite to the sulfur. Chlorine reacts with H2S. This is a familiar reaction. It forms 2 molecules of HCl and sulfur. That's all. So, the quite familiar reaction, this one. Next one. Displacement reaction, which means it has an ability to replace one halogen. So, chlorine reacts with KBr. So, it forms 2KCl plus Br. So, thereby halogen has been replaced. Similarly, chlorine will react with the potassium iodide. Potassium will take up the chlorine and goes as 2KCl and iodine will be removed from it. So, that's what it's a displacement reaction. Then the next one includes the formation of the addition compounds. Formation of the addition compounds includes firstly this chlorine, okay, this chlorine reacts with the sulfur dioxide, carbon monoxide and ethylene and forms an addition product. So, this is what generally it has been given. It can form just like an addition product, which means it combines with it and forms. Just for an example, I will write, examples are given here. Okay, ethylene C2H4, which I will write in terms of a bond, CH2, double bond, CH2 plus Cl2. So, double bond breaks, it forms CH2Cl CH2Cl. So it's an addition reaction. Then carbon monoxide reacts with chlorine to form carbonyl chloride, COCl2, phosgene. Sulfur dioxide reacts with chlorine to form sulfuryl chloride, SO2Cl2. Okay, so chlorine similarly can react in alkanes and forms and substitution products also. Okay, because by the replacement, I'll write one. Chlorine reacts with an methane to form, very firstly, HCl goes out, so it is CH3Cl. So hydrogen is being substituted by the chlorine in the product. So to show that it undergoes a substitution reaction. Okay, so this is what this reaction I have written here. Okay, so substitution reaction. The next one, benzene. Benzene here is reacts with chlorine in the presence of an FeCl3. One of the hydrogen will take up the chlorine and goes as HCl, thereby will be getting C6H5Cl. So chlorobenzene is a product. Okay, so this is the reaction to show that it undergoes both addition reaction as well as the substitution reaction. Uses of the chlorine. Chlorine is used for the purification of the drinking water. Very firstly, nowadays it has not been used. RO is being very familiar here. So it has been used in the very the days which we have come up. Okay, the bleaching, it is used to bleach the cotton textiles, paper and the rayon. See, it has an ability to decolorize the color substance permanently, so it can be used as a bleaching material. The next one is it is widely used in the extraction of this gold and platinum, because during the formation of the gold, so it forms auric chloride, AuCl3. Okay, so that's the reason it is widely used for the preparation of this or the extraction process of this gold and platinum. Okay, so in this content, what we have seen is we have come up with what are all the general trends in the halogen family, and we have begin with the chlorine preparation method of the chlorine includes both electrolytic process and the decant process, then followed by physical properties and chemical properties also. The very important part of the chemical properties is reaction with excess chlorine and the excess ammonia is very important reaction. Then the bleaching action of the chlorine is permanent, that one we need to do. And reaction of the chlorine with the sodium hydroxide. Okay, that is a hot concentrated, cold dilute sodium hydroxide. Very important question. So in this content, these three are quite important question, and the preparation method, as I said, decant process, electrolytic process is also very important. Okay, make sure that here it is not very difficulty in balancing as we have seen in nitric acid and the sulfuric acid. It's quite easy. Okay, so nothing to worry. You have to know what happens, what reactant, what the product. That's all. So with that, you can able to find out. In the next session, we'll be looking into the interhalogen compounds, then followed by its structure, oxides, then hydrochloric acid also is there. We'll wind up in the next session with the group 17, and followed by we'll proceed with the group 18. See you all in the next session. Thank you.